are back again. Okay, so we're pretty much exactly where we left off last time. I haven't really done anything here. I think I moved the cursor up and down a little. That's about the extent of what I did. But I thought a bunch about what I want to do. So, up here is a little example of what I want some of the language to look like. So here, what I'm imagining is we've got some people, and they can maybe within a company, say, you can either be the CEO, I left a class out, you can be an executive, you can be a manager, or you can be a worker. Right, so this is the type or the class of the employee, and this is declaring an employee. And then declaring the types of employee that exist, the classes, if you will. Then we have a person, which can have a bunch of attributes. So this is not actually part of the language. It just stands for a bunch of other stuff can be here. And then one of the things that can be there is the class, right? And then we want to know if one employee or one person has power over another person. And there are three ways that can be true. Either one, the CEO we're just going to say they have blanket power over everybody, right? So if the first person is of class CEO, then they just blanket have power over whoever the second person is. If the executives have power over managers, which if the first person is an executive and the second person is a manager, then the executive has power over the manager. Or if the first person is an executive, the second person is a worker, they still have power over them. And we will add we will leave out the last one, which would be that a manager has power of a worker. Because, maybe they don't. Who knows? It doesn't matter. It's not super important. This is just an example of what it looks like to define a couple of types. And in the spirit of dependently typed languages, you can only have an instance of this has power over so having an instance of has power over is the same thing as proving that person 1 has power over person 2. Right? So if you have an EOW, right, if you can supply an EOW to a function, that's a proof using the fact that executives have power over workers, this little constructor, but it is a proof that person 1 has power over person 2. All right, so I'm not going to go through all the syntax of this step by step. I've given a little bit of thought to this, but it's not set in stone. But the important thing to note about this is I want all these to be macros. This def type and this def struct, I want those to be macros. I don't want those to be the primitives of the language. I want this def type to do some simple transformation over its inputs and then yield out the primitives of the actual language. And those primitives are, well, here are some of them. The first one is claim, which associates to an identifier a type. So here class is itself a type. So the type of class is type. This 0, if you know about universes or type levels, I guess, this 0 just indicates level 0, type level 0. So class is itself a type, and therefore the type of class is type 0. Class CEO is of type class. Class manager is of type class. We forgot claim. Class.executive is also of type class, and then class worker is of type class. Okay, so these are just setting up types. They're not definitions. So the definition is this alias part where we left them out again, where the definition of the class type, if you will, is that it is one of, right? It's a sum type. It is one of CEO, executive, manager, or worker. And the definition of CEO, that's just a primitive value. The class.ceo is just primitive. It doesn't have a further definition. And we also left out this one as well. And so in particular, primitive is primitive to the language, right? Like this is not some function you can write in our little language. Once the compiler recognizes this, it understands, you're trying to use a primitive value that is unlike any other primitive value. And in particular, every time, this is like, I guess, something like the hygienic macros generating symbol, right? Something like gensim or something from Lisp or Scheme, whichever. And that every primitive value is different from every other primitive value. We just happen to have captured this one by an alias. All right, so claim and alias are and I guess claim, alias, primitive, and sum are the fundamentals here. And they get built up into this def type macro. And def struct, I actually want to be a macro which simply does compile down probably into a def type, but maybe directly into just claiming that person is type, which comes from here. And then aliasing person to be a product type of all the other stuff that we haven't included. And then finally, person class is a class. I haven't exactly settled on how I want this to work, because this is more anonymous than, this is setting up a bunch of other primitive values, which just aren't really needed in the person case, because class is not, you could say class is a primitive of, I don't know. I haven't exactly sorted out how I want this to work, but it's something like this. Maybe it'll just compile down to the def type, but then the main problem is in that case, we need to decide what the constructor is called, and I don't know a good way of deciding that. Okay, and then finally, this has power over one, which is a little bit more complicated because it takes in what do you call these? Are they called type parameters? Possibly. It takes in parameters in order to make the type. So has power over itself is not a type. Has power over requires two people in order for a type to be made. And that's done pretty much the way you would expect, which is the case that has power over is really just a function. This is a function type, which is again going to be primitive in the language. Or I have used the word primitive here. This will be sort of fundamental to the language, this type, or this function type. And if you give it to people, then it will give you a type back. In this sense, right? So if you give it to people, then has power over is a function where if you give it to people, the result is a type. And has power over CEO. It's similar. You need to implicitly or explicitly. We'll come back to that in many hours. But anyway, you need to give it to people because that's just part of the definition of the has power over type. And then you also need to give it a proof that I guess this should be person.class. The class of person1 is CEO. You need to supply it a proof of that. And I guess we've left the same thing out from over here. And then similar things for the executives have power over managers and executives over workers. Which is basically the same. You just need to supply it one more proof, and then you finally get something of has power over P1, P2. And how these actually work is this is simply a lambda function where you give it two people and a proof. It completely ignores the people because they're just not necessary to actually constructing the type, because in the type all you need to remember is the proof. And here we've got the same primitive function, I guess, as before, but the difference is we've supplied it with something, and my intention here is that you can pattern match on that, right? So you can pattern match on has power CEO and extract the proof out. Extract the proof out of that. And again, similar thing here with these two. Now there's just two proofs that you can pattern match over. And then has power over is lambda, which takes in your two people and returns a sum type over these values. So, okay, let's start noting down from here what our basic operations are. Fundamentals. Fundamentals. That's kind of weird. Whoops. I don't know, something like that. What do we want? We want claim. That's the first one. Claim. Where this is a links, an identifier, and a type. Right? And then we want alias, which links an identifier and a value. So I guess we could have called this type and this value, but I don't know, claim and alias are fine. Then we want prim, creates a new primitive value. Also for pattern matching. Then we have sum, which creates a new sum value. That's a good question. Has power over. Yeah, has power over itself is type. Yeah, so has power over is itself a type. So yes, this is, I guess, strictly a sum type. Sure. Sum type. I guess that's correct to say. Prod creates a new product type. Then we have lambda creates a new function value, I guess. Creates a new function. We have this symbol, which stands for creates a new function type. No. Yes, creates a new function type. And what else do we have over here? I guess we have equals and bind. I guess I should mention those. Equals, this is like structural equality, I guess. Is it structural? I'm not sure. Equality, unwrap all the types. All the definitions. Right, we have bind. Yeah, so bind a name at the type level to a parameter, to a yeah, parameter, that's fine. So the thing to note here is this P1 and P2 are not the same. So this is EOM. This P1 and P2 are not the same as this P1 and P2. So these ones only exist at the type level, right? Because you need to be able to do things such as, you know, instantiate new types or get values out of types. So this only exists in the type level, this bind. Whereas this one, so this is what, EOM, whereas this one here exists in the function itself. And in this case, just isn't used at all.